Okay, I just wanted to put together a short video here talking about number 6 on the Limits Lab document, since there's people, some of you will be in class, some of you will be at home when doing this. So in number 6, we're trying to determine this limit. Okay, now it's sort of maybe not intuitive based on the problems that you've done up until now on how you would compute that. And so what the lab asks you to do is it says, all right, well, look, if you're looking at the limit as h approaches 0, you've got h here, you've got h here. You also have x's. You probably don't know how to deal with the x's right now. So what we can do is let's put in numbers for x and then see what happens. Okay, so I've given you this table here that you're going to sort of fill out. So when x is 2, in other words, when I'm trying to figure out what this limit is, what is the limit, right? So you figured it out there. And then you do the same thing for 3. And then you do the same thing for 5. And then over here you pick a fraction. Now you should make it like a fraction, not like, technically 5 could be written as 5 over 1, but make it a fraction that's between 0 and 1. And then figure that out and fill out the table and see if you can figure out what the pattern is. In other words, the question asks mainly here, what function emerges as you compute this limit for different values of x? So can you predict then what this limit is when f of x is natural log of x? What is the limit based on the pattern here? Okay, so that's what I want you to do. And what I've done is I have given you a very, very simple Desmos graph here that I'll show you. I think I've got it open already. And what this does is it just gives you a quick way to compute these values. So if you want to know, so I've plugged in 2 first. If you want to know what it is when h is 1, right? You just take and plug in, or drag the slider if you want, but probably easier just to type it. Just plug in 1. See what do you get for h, right? And so you get 0.405. Or you look at your table and what do you get? What about 0.1? Well, you just plug in 0.1 for h, and you can see right here that the value will change. Okay, and then you can sort of fill in the values quickly that way. I also recommend that you work with other people, and maybe you can cut the time down on how long it takes to compute these. But by doing this sort of tabular evaluation, experimentation, I guess you'd say, you'll figure out what the pattern is, and then hopefully you can answer the overall question. But that's just something I usually address in class, and since we're not all going to be in class at the same time doing this, I wanted to put that on video because it can just be a little bit confusing at first. So that's it.